This is TWiT.
When we asked Alex to come up and do the show with us, we said, and do you have anything new and cool you could show us? You came up with some interesting stuff.
Well, it's something that we've been dealing with, we've been working with a lot. And so, and for the last 20, 25 years, I've been doing some version of, I got to take photos and I got to put them into 3D models, you know,
I remember,
use.
was it on Call for Help?
I think it was,
you came with a, or was it the old screensavers?
I think it was screensavers.
You put a magic marker and you put dots all over my face.
Right. And that was probably a solid 10 years ago, 15 years ago.
At
so
least.
It's been, and
then
that was,
what? You took pictures?
Took a couple photos, and then I had to go through and by hand identify things and paint them all out. It was a process, you know. And
not to mention getting that magic marker off of my face.
I shouldn't have used a permanent pen. That's all I'm saying.
The Sharpie was a bad idea.
My bad, yeah.
So we've come a long way. You don't have to do that anymore.
You don't. And the tools just keep on getting better and better and better. A lot of the technology, whether it's for the stuff that I do, where I just need to get a 3D model, a lot of times you can use this to either use it as a base that I'm going to build a proper 3D model from, or sometimes you can just use the data that you actually scanned. Now this gets interesting when you think about throwing into VR or AR. Having that 3D
That's probably why
information,
there's a big demand for this now all of a sudden.
Suddenly
right?
exploding because of that. AR and VR are definitely pushing that, and that's why we're paying attention to it a lot.
Right.
Or accelerating what we've been doing for a long time.
Filmmakers have used this for a decade to
Absolutely.
create models in their CGI, their computer graphics.
It's used in everything from, it's photogrammetry is being used from construction to military to filmmaking to all these things. How do we gather this information? And sometimes that information is so big that it's really hard to gather any other way other than with pictures.
So photogrammetry is what you're calling this?
That's the first step. That's the little version. So the photogrammetry is something that anybody can do. You can download, and I'm going to show
no magic marker required anymore.
No magic marker required.
You just take pictures?
As an example, I took a couple photos of this little desk here.
Okay.
So if you look here, this is, here are the photos that I took. And what you'll see is that I just kind of moved around.
Now this is in an app called Photoscan Pro.
Photoscan Pro or Photoscan Pro is pretty expensive. Photoscan is a couple $100.
Okay.
But you can download the demo and do everything that I'm doing right now. So if you want to play with it, fully operational, you just can't save.
Didn't Adobe offer an app for your phone that would do this?
Autodesk. So they had 123D Catch.
That's it. 123D
But they've
Catch.
taken it down. So
What?
I don't know why.
They want to make money on it. Because it was a free app.
I think that we did a lot of work for them by taking lots of photos and uploading them.
Oh, they got what they wanted.
And now they have it incorporated into Recap and some of the other stuff that they have.
Okay.
And so they have a huge lift for photogrammetry. Now, what I did there is I took this and I just said, go ahead and process it. So I didn't do anything to this other than grab the photos.
It looks grainy though. Is there a
that's
reason?
just because it's scaled down a little bit.
Okay.
And then this.
That does look grainy.
Yeah,
That's
but
a 3D image.
This is a 3D model. So now this is uncleaned up. This is just I pushed the button and said go. Now this may look really rough, but now if I was building something, it is so hard. Before I would have had to measure everything, figure out where it all is. Now I can sit there and just go, oh, I'm just going to build a polygon here, and I know that it's perfectly where it was. And now I can build a clean model if I want to with more photos.
On top of it, maybe?
On top of that, just snapping to those points.
Got it.
And the big thing is that I can also, if I brought in a 35mm camera or even a medium format camera and took a bunch of these photos.
So that was just a camera phone and a handful of photos.
It's my iPhone and 7 photos. If I came in and took 20 photos with a higher resolution camera, I'd get much more data, and that data would be cleaner. And so that is a great way, especially if all you have is your camera with you, to gather some information. It's good to take, if you're going to do that, it's good to measure one thing. So like if I want to scale this, measure from point to point, so I know what this is, and then I can rescale that whole scene.
You know everything from
there because it's all based on that. And so that is that's photogrammetry, and that is if you're in the field, if you don't want to carry a bunch of equipment, that's the way to
capture it. Or it's a
static
image.
Static thing. And like for instance, I have some friends that do a lot of basketball players, football players for different sports games.
So you can do people.
So what they do is they have literally 150 cameras.
Yeah.
And you sit like this, and all 150 cameras take a picture, and then it uses photogrammetry to develop a 3D model.
So is that what they do if they're like capturing a basketball player's dunk? Or just if it's static?
They're using photogrammetry for that dunk, but it's using the video, and it won't be as high resolution. You'll notice the one in the NFL where the guys were kind of turning, that's photogrammetry.
Okay, yeah, now they use it like crazy on television, on NFL. They have all these great graphics of the guys.
That's photogrammetry. That's photogrammetry.
So they brought them into a studio and they had them go like this,
Right.
and then they got 150 shots at once.
Well, and those ones might even be less. They might have had 10.
Right.
You know, and they just go. You just sit there and you do whatever pose you're going to do.
Right.
Now they probably did that on the day of the game or the day before, and so it was a little. What I noticed in Super Bowl, a little low resolution, but from compared to what it's possible,
it's pretty cool.
But still pretty nifty. And so that is the that's where. That's photogrammetry, and it's good for things that are like human beings or animals or so on and so forth, or you can't carry the stuff around. Now, once you want to grow from there, and when you're talking about industrial, so you want to do construction, you want to gather really, really accurate data, you start looking at LIDAR. So LIDAR is your laser scan of an entire scene, and fortunately, I have a friend who has a lot of LIDAR.
Let's go take a walk. Because joining us right now, Fred Feickert. He is a principal at F3 and Associates, and you guys use LIDAR to what? Take pictures of stuff in 3 dimensions.
Yeah. So if you think about it, it's reality capture, but what it does is the easy way to think about it is millions of points.
Yeah.
And then, if you glued them all to the table, then that gives you the 3D model of it. And all these are...
This is all LIDAR we got here.
Right.
Now, LIDAR is a familiar name to me because of self-driving vehicles. Don't they have that spinning LIDAR on the top that's making a 3D image in real time as the car moves?
Yeah.
Is that the same thing?
It's similar. And then, a lot of the cars are going to more, I think they're going more to flash LIDAR, things of that nature, stuff like that. But for us, we're a surveying company, but we realize really quickly with like 3D printing and these type of things, you have to interact with the environment, and so they capture, just that.
So you brought some stuff. This is the budget LIDAR. This is Leica. Okay.
And that's a BLK 360.
Yeah.
So this is inside here. It's radar, so it can go through a plastic housing, right? It doesn't.
No, it's going through there.
Oh, there's a little gap.
Yeah.
Oh, there's a little. Okay. Does
So
this
it's spinning.
spin?
It spins, yeah.
Okay.
And one thing to realize too, if you think about it, is the Leica has versions of all these as well. So
Leica makes the whole range, but this is, how much is this for my home use?
That one, I think they raise is about 18,000.
Okay, never mind. All right. So by the way, that was one of the points of the lawsuit between Uber and Google over the Waymo lawsuit, and their engineer who apparently stole Google's low-cost LIDAR implementation. They'd figure out a way to get it to about the 10th of the cost, which is a huge deal in self-driving cars. An $11,000 LIDAR unit versus a $1,000 LIDAR unit, that's a huge deal. So these are expensive right now, but I presume they're going to come down as better technology.
This is the actual process. The ones behind you are a little bit more expensive.
So what are these? So let's talk about these here.
Those are just bigger, basically bigger versions.
Almost cost myself some money. Tell us first about this big boy here.
Okay, so that's from ZNF, and that one will maxes out at 1,000,000 points per second.
Does this spin also?
It spins, and then this spins as well.
So inside here, there's a little mirror or a little camera. Is it okay for me to do that? I guess not. And that's going to spin inside, and this is going to spin outside. And the idea is it's going to image as it's spinning. It's going to capture.
What it does is the LIDAR goes out, collects, it'll max out, like I said, 1,000,000 dots per second. But then also why I use it a lot with Alex is because it does HDR imaging afterwards. So then it glues so every dot ends up with a color.
Okay.
And then what they do is this one does high dynamic range. Now we use a lot of the P40s that, again, it would be the Leica equivalent, but this one's a little bit more in line with the stuff that
How much is this?
Those go 80 to 100, depends on, they all have various models.
Right, right. This is from Faro, this one down here? Tell us about this. It's all the same idea, though, spinning, capturing.
Right.
Yeah.
Faro is really...
What do I get when I spend 10 times more money? A higher resolution image?
More accurate, and, collection rate. There's so many, and they all have versions, right? So this is like the X130. We have there's a S class and S150s. But Faro is really interesting because they have probes. They have a large instrument line. Like we use it for metrology and things of that nature. And it kind of is a real good in the middle, but they also have a really wide, range of stuff.
Interesting.
Right. So this is really used a lot in construction.
Here's a name you're going to recognize. This, and by the way, it's interesting because these are on what looks like surveyor tripods. Do surveyors use these?
Well, I'm a surveyor.
Oh! So your world has changed a lot in the last 20 years.
This would be like the dream instrument we always talked about. And the SX10 is really interesting because if you think about these just collect the environment. This one interacts with the environment. So like when we're laying out high rises and things of that nature, this you could lay out. And what they did, there's a really interesting article when they built this. They said, what could you do if you put a scanner inside of it? And this one does 30,000 points per second, I believe. But you could be working, you go lay out a bunch of stuff.
So when I see a surveyor, it's two guys. There's one guy on the big one, and there's a guy holding a pole. Do you still have to do that?
No, this is like, so it's all robotic now. So this.
But what's this?
This will track
this. Goes with that.
And so
okay.
Now it's funny is like.
So it's bouncing light off of these prisms in here.
To lay out, right.
Okay.
And so if you think about it though, what's interesting, this one you used to be able to look through it, even the modern instruments. Yeah. This is the first one because it has like multiple cameras in there. And it does photogrammetry as well, and you operate with this. So you could go running with that thing, and that would go and pick you up.
So forgive me for not understanding your business very well, but in the old days, I thought a surveyor was looking to find property lines and lines of sight and elevations and stuff like that. This does that?
It does that as well, yeah.
We'll make a 3D map of whatever it is you're surveying.
We specialize in a lot of like construction, so bridges, dams, tunnels, things like that. But yeah, we still do some boundary, and so it basically is like a Swiss. So this is my favorite.
Swiss Army knife is what you're about to say, and this is from
Trimble.
Trimble, which I've heard of for years as a GPS navigation system. They've now found a new business for themselves. All right, so now that we understand how much money you've spent. Oh, by the way, this also goes with the Trimble. This is a little GPS device so that you can match those points to their actual location in space.
The reason why I brought that is because we're going to do an example where we did a whole golf course. That's the Trimble R10, and what's interesting, the R10 model, I don't want to get too tight, but it's like what they call high definition GPS, where there's a whole new solution model that particular unit does.
So it's more than just there's a dot, there's a dot, there's a dot.
It's different from like the R8 models and stuff.
Well, you were telling me that, for instance, when you're surveying a building, you would survey it not just at the beginning, but all along the process of building this building. So you now have a series of, it's not an elevation anymore, it's a 3D maps of what's in that building.
Right.
So every step of the way.
Yeah, so we'll lay it all out and work with the contractors, but also we'll be scanning as we go. So if you think about it, it's as-builting.
It's a real as-built.
Yeah, and so it's, or like we use a lot of it in refineries, so where pipes are connecting and things.
So if they had to make a repair, they'd know exactly where they're going and what's in that wall.
So as you build as you go, and you have it with the BIM models, but then also if you think about it for maintenance, you could literally, know what's behind it, and so 3 years from now, you could just go right to that spot and nail it. Yeah.
Now, earlier you were messing around in here. What did you guys do?
So we just did a quick scan.
Should I ask?
Yeah, so I did it with the ZNF.
Okay, you scanned our studio.
Yeah, I did a quick setup. But so that's the studio. And so
I could do that with my camera phone. Wait a minute, hold on there.
But what's interesting
about... So it's a 3D map of the studio.
Right, so that's actually all the dots, right? But what's neat about this, if you go back to rear view,
compare that to the photogrammetry.
Right. So then if you wanted to get a measurement from, say, there to the desk, well, anywhere like there.
And that's how accurate?
Well, that one there, we always say like 3 millimeters, eighth of it. There's a lot, obviously, that goes into that. The specs on that are pretty high. How you mesh the clouds, how far you go, but there's a range.
And one of the things we've started to do is we do a lot of events that are in different locations. And so when we do our site visit, we're starting to scan. We take this, we just throw that scanner in. Now, when we're having conversations for the next 2 months before the event, we go, how high was the ceiling right here? And we just draw a line and go, oh, it's this high.
Awesome.
And then if we want to build for our clients, we can take that 3D model, we can put it into VR, we can add all the chairs and the staging and everything else, and they can see exactly what it's going to look like before they get there.
That's really
cool.
cool.
And so that's that's some of the power. And
how long did it take to do this 3D model?
Well, it took like the scan maybe 9 minutes.
Not long.
Yeah.
Not long. Long enough. No longer than taking photos of the site.
Much less.
Much more.
And much more accuracy.
So,
and this is all the way around.
Yeah, and that's all 3D. That's a 3D model. So it's so you can see he's snapping to anything that's there.
It's all in there now.
It's all in there. All those dots are there.
So in effect, you measured every surface.
Everything's measured all at one time, and then you can go back and do any of the measurements that you want. So if you want to make any updates, and then what we did last summer was we did a golf course. So the challenge is how my family has a golf course in Pennsylvania, Birdsfoot, and we. This is the golf course. My brother was willing to let me run around and put a bunch of little nails in his golf course, and the challenge here was it's 2.5 square miles of.
That's a lot.
And so how do you get all those scans to tie together? And that's what we use this Trimble for, because if you look at where those numbers are, those are all
GPS.
That's the GPS points of where we knew. That's where we scanned.
Right.
So
you can actually stitch these together perfectly, knowing exactly where everything is. What would you now? Why would somebody do that? What would you want that information for?
So the concept here, that we're starting to test, is if you think about when you have that data, you can now build extra things for AR, extra things for VR. So imagine being able to pick up your phone and look at. It'll range out for you from where you are.
Golfers
where that is.
would love that, right? They could say, "Here I am. How far is it to the hole?"
And it also knows not only how far to the hole, but the grade,
what's the elevation,
everything.
What's the grade? Wow.
It knows everything about that, because we have all that data down to less than a ½ inch and over the entire thing. So,
how about gaming? It feels like this. You could do this for gaming.
Absolutely. When you're trying to absolutely grab, and when you look at the data,
that is so cool. It looks like your golf course is on the moon, but other than that.
If you look at it's literally, when you look at that zoom in, it's actually getting the grass. Like if you zoom in a little bit,
it's that detailed.
It's you can see the different how they mow the grass,
the rough versus the green,
and all the that's all the texture in the sand hole
trap.
So it's an incredible amount of data, and we can then class that. For instance, if we wanted to simulate how a ball goes across that. Oh, this is deeper grass. This is thinner grass. This is sand. This is all those other things. This is the actual where we get our hot dogs.
Yeah,
the hot dogs
you
are
can
very
see
good.
I called it hot dog.
And but yeah, you can see all the trees. You can see everything. So, but yeah, for games, especially if you want to gather something that's very specific, like I want to reproduce a location in the game. Your fastest way to do it is to do LIDAR. Now, you may decide you're going to then remodel it.
A designer's going to go in there with those data points and make it something else.
But it's so much faster.
You've got a starting point that is incredible.
Exactly.
Yeah.
Now you can just snap to those points and start building out all of your network, and it's going to cut your modeling time down by 60 to 90%.
And if you think about it, right, every one of these dots has a true color. And it's positioned because I came in with a GPS network at first, so it knows exactly where it is in the world. And then you can snap literally from a branch at one side of the golf course and get a distance to, a sign at the other side.
So this is the beginning of modeling the world, basically.
Yeah.
And we've seen interesting uses. A few weeks ago, we had somebody come in they had used LIDAR from airplanes to discover ruins in Central America that no one even knew existed, and they have found now. I think there were Mayan ruins that with basically cities the size of New York City that no one knew about because they were under the canopy. This is amazing what they can do with this.
And we're also experimenting with mixing the photogrammetry that I showed earlier and the LIDAR, because the LIDAR captures all of that stuff, but it's really expensive to start capturing every little divot. But what we've done is taken a drone, taken a whole bunch of photos. We then sync those photos to the LIDAR that we have here and kind of fill in all the spaces that we didn't, that don't need to be quite as accurate, but we still want to make sure we cover them all.
Wow.
And so those are the other things you can do with a mixture of drone and LIDAR and photos, and it's not one or the other. It's a lot of times it's all of it.
Yeah, really, really interesting. So this is a use of LIDAR that we've heard so much about the cars, that this is a whole nother use of it. Is this, now, I've heard there's two different kinds of LIDAR. There's time to flight.
Yeah.
And what's the other one? I can't remember it. But one measures, what is it?
Phase-based.
So one is measuring how long it takes a light to bounce off, and come back, right?
And the other
that's
one,
actually how our lighthouse works. It has a little LIDAR sensor in that camera, and that's how it's making a 3D model of the world around it. That's easy with a static scene, right?
Right, and they're just different technologies. Like, it's really interesting that actually, I think it takes the beam and splits it into 3. You know, that's a phase-based. A lot of the P40s.
How does phase-based work?
It's, well,
if something's in phase or out of phase, it can tell.
It's how the wave comes in, I guess.
Yeah, I got it. Yeah. Very interesting.
It gets.
This is cool. This has really changed your business.
Oh,
when you started in surveying, were you just, holding the pole?
We started. We always did
measuring
construction.
things.
Yeah, and then what happened is that because we're so involved in construction, I think we just kept in the larger buildings and stuff like that. So we've always had to stay ahead. It's like the 3D printing. We did that because a lot of times at that time you couldn't interact with the environment, with the computer. And so we would print it out and the guy would say, okay, here's your dam gate, or here's your piping that goes in. And so
I'm sold. I remember my college roommate who was studying architecture doing foam core models with an X-Acto knife.
Exactly.
And that's long gone.
Yeah, now it's all computerized, And so, it's, and I think the other thing that's been really interesting is the convergence of all the technologies, like me and Alex working together, but, and a lot of these new companies that are coming through, but I'm ending up in, we were ending up in a lot of industries that we never thought we'd be in.
Yeah, I think that's interesting. So obviously construction, and that's kind of a natural surveying, segue. But now you're thinking about surveying a site for a later broadcast where you want to set up all this stuff. What a great use for that.
And then when you think about volumetric, so the next big thing for VR is volumetric VR, which is that I'm no longer in just one place and looking around. I can walk the entire size of the set and get a sense of it. Now, how do you gather all the data to walk through that entire?
That's a lot more data.
So LIDAR is the beginning of doing a lot of those things. And you may model some of the rough stuff, but imagine, like, for instance, using LIDAR to scan statues or scan something that's really complex that you're not going to want to try to model by hand, and it's something might be historical, but I want to be able to walk around it as a viewer. Those are the kind of things that LIDAR becomes really useful
Is
for.
it reasonable to think that this stuff is going to get less expensive and more widely available, and there'll be more applications because it'll be cheap and you can do it and do things you would never have thought of before? Maybe you have a 3D model of a convenience store and, I bet you Amazon's doing this, and then you know which items have been taken off the shelf because it doesn't match the model.
Right. Well, and the cars are driving the price down. I mean, when we looked at what we have in all of our phones, those were very, very expensive spy cameras a long time ago. That when they got released, now they're nothing. And so that's definitely the trajectory. But it'll take another 10 years before it's.
Fred Feickert is a principal at F3 and Associates. If you want him to come and map you, he could bring the big boy, the Imager 5010C, and really get a detailed 3D map of your next project. That is really cool. Fred, thank you for bringing all these fun toys by. This is really, really neat stuff. We hear so much about it, but to actually see it in action is really cool.